So let me ask you something before we begin. Every time you connect to the internet, from home, a cafe, or an office, how confident are you that your data is truly secure? Because the truth is, most data doesn't travel as safely as we think. Welcome to Bluehat Cybersec Academy. Today, we're going to talk about one of the most important technologies behind secure communication on the internet, IPsec VPNs. And by the end of this session, you'll clearly understand how site-to-site and remote access VPNs actually work in the real world. When data travels over the internet, it doesn't move in a straight, protected line. It passes through multiple networks, many of which you don't control. That's exactly where VPNs, or virtual private networks, come into play. A VPN creates a secure, encrypted path between 2 points. This keeps your data private, even when it's moving across public networks. One of the most widely used VPN technologies is IPsec. So let's start by understanding what an IPsec VPN actually is. IPsec stands for Internet Protocol Security. It's not just a single protocol, but rather a set of standards designed to secure IP traffic. What really makes IPsec powerful is that it works at the network layer. That means it protects all applications automatically. Email, web traffic, file transfers, everything is secured without requiring changes at the application level. An IPsec VPN creates a secure tunnel between 2 endpoints. These endpoints could be firewalls, routers, servers, or even individual user devices. And all data that passes through this tunnel is both encrypted and authenticated. Now, at a fundamental level, IPsec focuses on 3 core security goals. First, it authenticates devices. This ensures that both ends of the connection are who they claim to be. Second, it encrypts data. So even if traffic is intercepted, it can't be read. And third, it ensures data integrity. This protects information from being altered while in transit. Together, these 3 principles form the foundation of IPsec security. So, to make all of this work, IPsec relies on a few key architectural components. One of the most important is Internet Key Exchange, or IKE. IKE is responsible for setting everything up. It handles authentication, negotiates encryption settings, and securely exchanges keys. There are 2 main versions you'll hear about. IKE version 1 is older and mostly legacy. IKE version 2 is faster, more secure, and honestly, the recommended option today. Another critical concept in IPsec is the security association, often referred to as an SA. A security association defines exactly how traffic will be protected. This includes which encryption algorithms are used, how authentication is handled, and how long keys remain valid. It's important to note that IPsec uses one-way security associations. So for two-way communication, 2 SAs are always required. Now, when it comes to protecting actual data, IPsec uses 2 main protocols. The first is Authentication Header, or AH. AH provides authentication and integrity, but it does not encrypt data. Because of that limitation, it's rarely used in modern networks. The second and far more common option is Encapsulating Security Payload, or ESP. ESP encrypts data, authenticates traffic, and ensures integrity. In real-world deployments, ESP is almost always the protocol of choice. IPsec can also operate in 2 different modes, depending on the use case. In transport mode, only the payload of the packet is encrypted. This mode is typically used for direct, host-to-host communication. In tunnel mode, the entire IP packet is encrypted and encapsulated. This is the most common mode for VPNs, including both site-to-site and remote access deployments. Speaking of deployments, let's talk about site-to-site IPsec VPNs. A site-to-site VPN connects entire networks together. Think of a headquarters network connecting securely to a branch office. Each location uses a VPN gateway, such as a firewall or router. These gateways establish a permanent IPsec tunnel between them. Once that tunnel is up, devices on both networks can communicate securely, almost as if they were on the same local network. Site-to-site VPN is, honestly, a pretty common approach when you need reliable connectivity between branch offices, data centers, or even for hybrid and cloud-based environments. It's a go-to solution for securely linking different locations. Now let's shift focus to remote access IPsec VPNs. Unlike site-to-site VPNs, remote access VPNs are designed specifically for individual users. Instead of connecting entire networks, they're all about connecting people. So, users will install a VPN client on their device, and after authenticating, an IPsec tunnel is created between the user and the corporate network. This setup allows employees to securely access internal resources from, well, anywhere in the world. Remote Access IPsec VPNs are widely used by remote workers, traveling employees, and really anyone who needs secure access outside the office. Behind the scenes, IPsec VPNs are established in two main phases. In Phase 1, the peers authenticate each other. A secure management channel is created, and encryption and hashing algorithms are agreed upon. Then comes Phase 2. This is where the actual IPsec tunnel is built. Security parameters for data traffic are negotiated, and once everything is in place, encrypted data begins to flow. So, to keep data secure, IPsec relies on strong encryption methods. The most commonly used encryption algorithm today is AES. It's fast, secure, and widely supported across devices. Older algorithms like 3DES still exist, but they are no longer recommended for modern networks. To protect data integrity, IPsec uses hashing algorithms. SHA-1 is now considered legacy, while SHA-2, such as SHA-256, is the current standard. For authentication, IPsec supports both pre-shared keys and digital certificates. While pre-shared keys are simpler, certificates are more secure and scale far better in large environments. So, because of this flexibility, IPsec VPNs are used in many real-world scenarios. These include enterprise network security, cloud to on-premises connections, partner and vendor access, and also protecting sensitive data over public networks. On the positive side, IPsec offers strong encryption, industry-wide support, and, seamless compatibility with all IP-based applications. On the downside, IPsec can be complex to configure, may face NAT traversal challenges, and introduces some performance overhead due to encryption. Alright, let's talk about the key differences between IPsec and SSL VPNs. So, IPsec operates at the network layer, while SSL VPNs actually work at the application layer. IPsec is really ideal for full network access, whereas SSL VPNs are often just simpler for browser-based use cases. Now, when compared to WireGuard, IPsec is definitely more mature and widely adopted. On the other hand, WireGuard is newer, it's faster, and honestly, it's simpler by design. However, IPsec still offers broader enterprise compatibility, which can be a big deal for many organizations. So to wrap things up, IPsec remains one of the most important VPN technologies in use today. It delivers strong security, flexibility, and reliability for both site-to-site and remote access connections. And while it can be a bit complex to configure, IPsec continues to be a trusted solution for securing modern networks. Thanks for learning with Bluehat Cybersec Academy. If this session added value to your understanding of networking and cybersecurity, give it a like, share it with someone who's building their cyber skills, and subscribe for more practical, real-world security content. Drop a comment below and tell me, are you using IPsec today or planning to implement it in your network? Until next time, stay curious, stay secure, and keep sharpening your cyber skills.